Okay, I'm not seeing my video. Okay, well, good afternoon. Welcome to the Explore Marvel Moon, Moon and You webinar. We're very happy to have you all here today. My name is Eve Halligan. I'm an Education and Public Outreach Specialist here at the Lunar and Planetary Institute in Houston, Texas. And very happy to be working with all of you today. Of course, it's my job to kind of share NASA resources and science with educators such as yourself and bring you resources and materials that you can use in your programs. So happy to have you here today. We do have a couple people here to be helping as well. Of course, I can't do this alone. So a few people I'd like to introduce to you first thing this afternoon. A couple of my coworkers in the education group here at the Lunar and Planetary Institute. First up, I'd like to introduce you to Andy Shaner. I'm going to have him step in front of the camera. Andy will be helping with some of the activities as we're working through the webinar today. So welcome, Andy, please. Notice he had to dip a bit. He's not quite as short as I am, unfortunately. Okay, so Andy will be helping with some of the activities today. Also behind the scenes, I'm going to have some great support. We also have Heather Dalton with us today, who will be helping with the chat box. So if you're having any problems with your audio or video, you can use that chat box to help let us know. She'll also be fielding your questions and helping make sure that they come to the attention of me and Andy so that we make sure that we're answering your questions and getting your comments as we work through the webinar today. And then along with all this, we also have Ramiro Padilla with us from our computer center. He's working very hard to keep our technology up and going and working smoothly for us today. Again, if you have issues, use that chat box. He'll work to resolve them with you quickly. And then finally, we have a special guest who's not here in Houston with us today, but joining us online. I'm happy to say Dr. Neil Cummins is joining us from the University of Maine, and he'll be talking with us in a little while about the moon and what it would be like here on Earth without it, giving us some science background. So I'll introduce him more fully in just a little while. But that's our crew here today. We're happy to be working with you, which brings us to all of you, of course. And so thank you for joining us. I would like to orient you a little bit with our platform that we're using for the webinar today in case some of you aren't familiar with it. We're using Adobe Connect, and so you should be seeing a few different windows. And so, of course, my slide's nice and big there. You'll see our video up in the left corner. And below, you should see the chat box. So during the main section of our webinar today, we would really appreciate it if you would use the chat box to send us your questions and your comments and any answers to our questions that we're putting out there for you during the webcast or the webinar. And so we'll keep an eye on that. So right now your microphones have been muted, but we do want to hear your voice. So later in the webinar, we are going to have a discussion with you. And we want this to be an interactive discussion, so we're going to open the mics up and give you a chance to share your lovely voices and tell us your thoughts and ideas about how you may use these activities and resources in your programs. Okay, so with that in mind, just a couple other features I'd like to point out on the Adobe Connect for you. At the top of your window, you'll notice a person with their hand being held up. And if you click on the arrow next to that, there's a function there where you can raise your hand. So when we do get to the open mic portion of our webinar, you'll be able to use that function to let us know that you have something to say. And that way we can try to minimize the background disruption with background noise and make sure that all of your voices are able to be heard. Also, up at the top, you'll notice the microphone icon with an arrow. You can check there. For now, please make sure that your microphone is closed and not enabled. But later in the webcast, when we open it up, you'll be able to go up there and click on that to connect your microphone so that you can chat with us live via the web. So with just a few details there to get us all used to the Adobe Connect. And now I think we're ready to get going. So it looks like everyone's able to hear and see us okay. So let's get going. First of all, I would like to give you just a little bit more information about the Explore program. The Explore program was designed to engage children in space and planetary science in the library. So this These are materials that were developed especially for you to use in your programs at the libraries. And these program materials are free. They're very flexible, so they can be used in a variety of different settings, such as your summer programming, after school sessions, anything from science days up to family events. So very flexible and adaptable to what your needs will be. And of course, we encourage you to take and use what fits and makes sense with your programs. And all these materials are very hands-on. So the activities that we'll be demonstrating and teaching you today will be things that will really get the kids in there and busy and actively learning the science that deals with, in this case, the moon. So, of course, these are all available online, free for your use, and we encourage you to visit the website to find those details. And along with that, then, if you're looking for the Marvel Moon materials, you can go to the website link listed here on the Explore. And in order to get to the Marvel Moon page, you'll just simply go over to the left side there where it says Topics, click on it, find Marvel Moon, and it'll bring you to the page and the resources for the Marvel Moon module. The Marvel Moon Explore module really looks into how the moon formed and evolved over time, and then it also looks at the cultural influence of the moon and what the Earth would be like without it. Today for our webinar, we're really going to be focusing on that second part, which is looking at the cultural connections and how our Earth would be different if we didn't have the moon. Would we even be here? So make sure to check out the website to find the activity write-ups, the background resource information, and then one last thing I'd like to point out with this module that's special to it is the comic book. And the comic book is a lovely resource that goes along with the activities, and it features scientists and researchers that guide your children in your programs through the activities as comic book characters. So we'll be showing you these different pages. This is what it looks like all put together. And this is something that kids can build as they attend the various activities and programs that you would be doing from Explore Marvel Moon. And the comic book is set up so you can use it either as a whole, or you can just print and use the pages relating to the activities that you will be doing. So you can customize the book for your programs. And you don't have to use everything that is there. So with that, we're going to get busy today and get diving into some of these activities. And for this first section, actually, I'm going to turn it over to Andy, and he's going to be working through a few of our opening activities today. So, Andy, here you go. It's all yours.
Thank you, Eve. And there we go, Ramiro. Thank you very much for popping that up so you can see me. Good afternoon, everybody. Glad to be here and chatting about the moon with you all for a few minutes, and some of the activities you can do in your library, which are pretty fun. They're pretty fun to do. And what we want to start off with is, I understand, Eve sent you all out some homework to do. That wasn't me, so don't get mad at me. Where she asked you to look at some resources she sent you that dealt with different cultural stories about the moon and different shapes you might see when you look at the moon. And so we're going to bring up our first poll, so we can all get some practice on using the poll. First question is simply, were you able to do the homework? Did you get a chance to do the homework? So just use your mouse and click there, and let's see who. Looks like a lot of folks did. And we have, how many do we have on? 28. Looks like. Okay, great. All right, so most of you were able to, so that's good. So what did you find when you went and you looked at these resources, and when you went out and hopefully got a chance to look at the moon? What did you see? So use your chat box in this segment here. What kind of stories did you read, and what kind of shapes did you see? And I'll give everybody a minute or so to answer. Let's see, a drummer man. Yes, that's a cool story. The rabbit from the two myths and the boy in the moon. Yep. Couldn't you just reading all the stories to find the shapes? It's here on the moon. Yeah, that's kind of sad. Okay, great. Yeah, a lot of the rabbit and a fox. I haven't heard that one. That's interesting. The Lady and the Lion. Yeah, fascinating. All right. I think my favorite is the Aztec story about the two gods that jumped up on I think it was the sun. But there was two different suns, and they jumped up, and they threw the rabbit on one of them because it wasn't as brave. So that's the moon. I like that one. That's pretty cool. Well, great. So you always did your homework, and you read some great stories, and you saw some of the shapes. Were you able to see the shapes then, once you actually read them? I read about these stories. Were you able to go out and see it? Now, of course, it's kind of hard if you weren't able to see a full moon for whatever reason, cloudy, or you just didn't get a chance to. But hopefully you got to see a full moon and could see some of those shapes. Some of them are kind of hard to see. They're kind of like clouds, where it's, you see what you see based on, it's like the eye of the beholder kind of a thing. But some of them are kind of obvious. Like when you look at this picture we have here on the screen, I can see the rabbit. That stands out to me pretty good. But I can also see the drummer that they talked about in those stories. But I guess that's just because I've seen them before. All right, well, great. Glad you got to go out and look at them and can see the shapes. That's fantastic. So we've actually done this with kids here at the Lunar Planetary Institute with some of our what we call Family Space Day activities in the past. And we had them go out and look at the moon, and here's some of what they drew. So there in the lower left, somebody saw Aladdin's lamp, which is that's pretty cool. On the lower right, a man walking a dog. And up there at the top, it looks like maybe some people playing catch. The first thing I thought was Grimace playing catch with somebody in a hat and a glove. Okay, but that's some examples of some things that you can see if you just use your own imagination and look up. And when you're looking at these features, at these things on the moon where appear to be these shapes, these outlines, these figures, you're making a really simple observation, actually, scientific observation. And even though you're thinking in terms of a story you have heard, or maybe just some kind of shape of something that you're familiar with in your everyday experience, if you just slightly take this cultural thing and turn it into a science idea by asking a very simple question, what are those two different colors? There's light areas, there's dark areas. Why are there two different areas, or colored areas on the moon? It's a very simple question you can ask based on a very simple observation, and it's a very simple answer on the surface. We're actually seeing two different types of rocks, two basic rock types. And what we've got here, Eve is holding up the dark rock, which is the dark areas on the moon, is called basalt, and the lighter color rock is called anorthosite. Now these are two samples from the Earth, and they're not lunar samples. The basalt you can find on the ocean floor. You can find the islands of Hawaii are made of basalt. The Galapagos Islands are made of basalt. You can find basalt in the southwest United States, New Mexico and Arizona, and other places. So basalt's fairly common on the Earth. Anorthosite isn't as common on the Earth, but you can find it in places like Montana. There's a mountain range outside of Bozeman where you can find anorthosite. So you're seeing two different rock types when you're looking for those shapes in the moon. Okay, so the moon is and has been important to many cultures. The month, okay, is based off of the lunar phases. Our month on our calendar. It's inspired poets, musicians. You can probably think of many different songs that talk about the moon in it. And the great thing about the moon in terms of science is just it's there. It's easy. Anybody can look at it. It's right there. Everybody is familiar with it. We know it's there. You can observe it and really easily. So that's also great. So this activity can be used as a standalone. You can just have your students or your children just use it. It can be part of a night sky viewing event like we've used it, or it could be part of an investigation into the moon's history. So the Growing Up Moon activity, which is part of Marvel Moon. You can use it as a beginning to just so they can make some basic observations about what the moon looks like right now. So there's a lot of things you could do with this activity, and unfortunately not always enough time to do all those things. So here's the page out of their comic. If you're doing this activity with kids and the moon's not out, or it's cloudy at night, they can use this page and they can look at a picture of a full moon and they can come up with their own outlines and even their own stories. All right. So fact or fiction with the moon? Everybody's heard different things about the moon, and maybe we're not really sure if they're true, or maybe they're kind of true or not true. There's a lot of things out there that are going around. So we got a couple of polls to ask you some questions about some things you may have heard about the moon. So this first one, has anybody ever heard that getting your hair cut during the full moon will make it grow faster? Is that true? Yes? Or is that false? No. Okay, we're split down the middle a little bit. Look at that. Okay. That actually is not true. And I can tell you from personal experience that it's not true. I used to always get my hair cut on the day of a full moon, and that didn't do me any good. So, that is not true. No, your hair will not grow faster when you have it cut on a full moon. All right, next poll. Hey, the moon pulls on the oceans and creates tides. Is that true or false? A lot of people going up saying true. Yeah, okay. One false. Got somebody. All right. Okay. All right, well, that is true. The Earth, of course, does have tides. That is true. And it is because of the pull, the moon's gravitational pull on the oceans that causes that. Yes, that's true. All right, next one. We see only one side of the moon because it is not spinning. Is that true or false? Okay, false is leading. Okay, looks like, okay. Hey, that is false. Okay, it's true that we only see one side of the moon, but it's not because it's not spinning. The moon does in fact spin. What's interesting is that the moon, right now at this point in history, the moon spins, okay, it rotates, okay, at the same rate, about the same rate that orbits or goes around the Earth. So we have an activity to help you visualize that better, and helps kids visualize this, because this is a pretty intense concept, I guess, to try to understand and to try to visualize. Very, very hard to see. So what we've got here, hopefully you have with you a penny and a quarter in the list that Eve would have sent out. So there's our quarter. And that quarter is going to represent the Earth, and there's our penny. That's going to represent the moon. And what you want to do is start off, or what we could do is start off, let's say, with both their noses. So Lincoln's nose and Washington's nose pointed at each other. So Eve's going to model. So Eve, just move the penny from where it's at now to about the 3 o'clock position. So over to the right of Washington. But just move it around. Okay, so what Eve did was she just simply moved it around. And right now, Lincoln's nose is not pointed at Washington. It's pointed away from it. Okay? But we know that the same side of the moon's face always faces towards the Earth. So in order for Lincoln's nose to always be pointing towards Washington, you're going to have to also rotate the penny. The penny will also have to rotate as it goes around Washington. So go ahead and try that. That's pretty good. So you can see right here, Lincoln's nose is not pointing at Washington. So go ahead and rotate it so it is pointing at Washington. And then as you move the penny, there we go. So as you move the penny around the quarter, you will notice that you have to actually make the penny rotate or spin as it goes around the quarter in order for that nose, the same face, to always be facing the quarter. So that's something that you can do to try to get across this fairly difficult concept, this idea that the moon does spin, but it spins at the same rate that it takes to go around the Earth, so we always see the same side. Okay. I think there's another poll. I think we have a few more. Okay, here's another one. True or false? People have actually been to the moon. I love this one. People have actually been to the moon. I am so happy. Well, let me give it another second before I say anything. Okay. I am so happy to see that nobody chose false. Yes. Human beings have actually not only been to the moon and going around it, they've walked on the surface of the moon. Okay, 12 astronauts did that in the late 60s and early 70s. And sadly, we did lose recently the first astronaut to do that, Neil Armstrong, passed a few weeks ago. But yes, we have been to the moon. All right, more babies are born during the full moon. Is that true or false? More babies are born during the full moon. Okay, we're a little split on this one also. All right, that's false. There have been studies that have done on this, along with other kinds of phenomena people attribute to a full moon, and none of these have shown the full moon actually affects anything like that. Babies are just as likely to be born on any day of the month as they are on the day of a full moon. All right, the moon has no gravity. This is another one I like. The moon has no gravity, true or false? All right. Okay, very good. That is false. That is a false statement. The moon certainly does have gravity. And you all believe we were on the moon, so if people had gone to the moon and you've seen the videos and the pictures of it, there's no way they could have stayed on the surface if the moon did not have gravity. So of course the moon doesn't have gravity. And in the resources for Marble Moon, there is a link to a video of the astronauts on the moon where they're jumping up and down. So they're jumping up and down, but they're coming back down, of course, because of gravity. There's also another really great video that shows an astronaut on the moon where he drops a feather and a hammer at the exact same time, and they both hit the ground at the same time. So that's an example of, yes, there is gravity on the moon because these two things fell to the surface. It's also a great demonstration of how there is no air resistance on the moon, air resistance, so they both hit the ground at the same time. Right? It doesn't happen on the Earth because of air resistance. Okay, I think that's it for the polls, I believe. Does anybody have any questions at this point about either any of the things we discussed in the polls, or the penny and the quarter activity, or the moon? What do you see in the moon activity? Any questions? Anybody have any questions about that? Feel free to type those in the chat box if you do. I don't think anybody's typing right now, so we'll go on. But if you have one, please type it in there, and Heather will pass it on to us so we can get that question answered for you. Okay. Okay, well, we've already done that. So Moon Mythbusters, this is an activity you look at some of these different myths and misconceptions that people have about the moon, and we explain that these are not, these are myths or misconceptions. A great resource is Phil Plait. He's known as the Bad Astronomer. He has a blog on Discover called Bad Astronomy. And he has a whole book actually on these myths about the moon and other astronomical phenomena. He's just a pretty funny guy too. So another part of this activity in the comic book is where kids get these puzzle pieces, and here's what one of those pages looks like. So these puzzle pieces that have statements on them, and some are true, there's 2 pages of them, I believe. Some are true statements and some are false, so are myths or misconceptions. And when they put these pieces together, they take all the true statements and put them together, and put all the false statements together, they'll get a picture of the moon. So all of the true statements will come together to form a picture of the near side, which we call the true blue moon. And all the false statements will come together to form a picture of the far side of the moon, or the far out, far side moon. So this is a way for them to read some misconceptions and some truth and sort out between them. And they should be able to know which ones are which after going through this activity. Okay, sorry. There we go. There's the puzzle pieces. And here's what they will look like when they come together. So you can see the near side of the moon there on the left, the true blue moon with all the dark areas. And on the far side of the moon, which doesn't have as many dark areas, as the near side does, those will be all the false or all the myth statements, incorrect statements about the moon. All right, getting to know our neighbor. Let's get to know a little bit more about the moon. We're going to talk specifically about And what I tell you about the scale, size and scale of the moon compared to the Earth and compared to the sun. So the moon is the biggest and brightest object in the night sky. Now, it's not always up in the night sky, but when it is the biggest and the brightest object. But most of us don't really have a sense of how far away it is, or really how big the moon is. Okay, how much space is there between the Earth and the moon? Okay, or how big or how small is the moon compared to the Earth and the sun? So what we can do is, since we all can't go out there and look for ourselves and take measure these things, we can use models to help describe these scales or explore these scales and take a look at it, at what these differences are like. So let's ask you some questions here about this. Okay, so if we use the sun as a giant pumpkin, and Eve, if you want to show that, this is a big leaf bag. It looks like a pumpkin. It's actually a little deflated since yesterday. But if you were to blow this up full of air, and if this was your sun, how big do you think the Earth would be compared to this? So if this is our sun, which is a big, maybe 2 or 3, maybe 3 feet wide, when you blow it up, how big would the Earth be at this scale? How big would the Earth have to be in comparison to the sun if this is the sun? Okay, got quite a few for a grape. Someone was saying a peppercorn. Everybody's guessing everything but bean. Okay. All right, well, it turns out it would be a grape. So if the sun were the size of this leaf bag, this big orange pumpkin leaf bag, it would be the size of a grape. So that's about 1/100th the size of the sun. So in other words, you could take the Earth and line up 100 Earths across the equator of the sun. Okay? That's a big star. All right, so if the sun is the big orange bag and the Earth is a grape, then which of those objects would represent the moon at this scale that we've set up? Earth is a grape. Okay, so we got a bean, which I believe is the white. The poppy seed is with the arrow, the little yellow arrow, the red arrow pointing at poppy seed. The peppercorn's just to the right of that. Okay, what do we think? What would the Earth be? I'm sorry, not the Earth. What would the moon be? We've already established the Earth as a grape. So what would the moon be? All right, it would indeed be the peppercorn. That's right. So the moon is about 1/4 the diameter of the Earth. So you could line about 4 moons across the equator of the Earth, and the Earth is 1/100th of the sun. So you could line up 100 Earths across the sun. So that's our scale for size. There's about one more. Okay. So if in this model, if the Earth is a grape and the moon is a peppercorn, how far apart would they be? In reality, the Earth and the moon are, on average, about 238,000 miles away from each other, give or take. So, with this scale, how far apart do you think they should actually be with this smaller scale? We don't expect you to actually know this or to do the math really quickly in your head. That's okay. So just take a guess. So we're talking either 1/4 of an inch, which on here is about half the size of that grape, an inch away from each other, 15 inches, or 3 feet, 36 inches away. Yeah, so the majority are saying an inch. It turns out the distance between the two would be 15 inches. So we can't even show you that here on our Elmo, because it's too small. But in reality, about 15 inches, so it would be the ruler plus 3 inches, so something like that. That's how far away they'd be from each other on this scale. And just to tell you, the sun would be about 490 feet away. So that's over a football field away from these two, if we put the moon's the distance to our sun in this also. Solar system's a pretty big place, and it's actually a pretty big empty place too. All right, so here's a page from the comic where they can the kids can write down, can draw how big they think the Earth and the Moon and the Sun are compared to each other. Can't really do distance here that easily, but they can at least do the sizes. All right, so let's move on to Mirror Moon. Let's take a poll here. All right. True or false? The moon makes its own light. Does the moon shine because of its own light? True or false? Okay. All right, that is false. That is false. The moon does not make its own light. We see the moon shines because it's reflecting light from the sun. So it reflects light like a mirror does, but it's not a perfect mirror. Okay. In fact, the moon only reflects less, I believe, than 10% of the sunlight that hits it. Less than 10% actually reflects back. But on a full moon, that's still pretty bright. That is still pretty darn bright. So we have a little activity here to demonstrate this a little bit. So we just take a tennis ball. Here. Yeah. Thanks. Take a tennis ball, okay, and a piece of aluminum foil, and wrap it around the tennis ball, which I've done here with this tennis ball. There's a little bit of a tail on it. That's just because I got too much aluminum foil. I wouldn't suggest doing this because it make it look like the moon has a tail, which of course it doesn't. But it makes a nice handle. So take aluminum foil, wrap it around the tennis ball, and really try to get the foil as smooth as you can around that. You want to make the foil smooth as you can, like a mirror, and not too bumpy. And so what we want to do here is show you. We'll put a flash, turn off those lights, and then we'll put a flashlight here on this. And you can see that's pretty darn reflective. That's pretty shiny. It's reflecting quite a bit of light. And we use aluminum foil. All right. Well, the moon doesn't shine back that much, okay, because the rocks on the moon actually absorb quite a bit of light. So let's just, for comparison, let's shine that light on a piece of basalt, which again is the darker areas of the moon. Here. There we go. Okay, let me move my hand back over here. Okay, so you can see that's not quite as shiny as this was. Remember, that's pretty bright. That's a lot of light coming off of there, and off of this dark rock. Not so much. In fact, you can even still kind of see the rock around the outer parts of that glow. So that's pretty dim. And if we shine it on the anorthosite, which is lighter rock, that reflects more than the basalt does. Okay? But so the rocks on the moon absorb a lot of the light, over 90% of it, that hits it. So it's not a perfect mirror, but it's like a mirror in that it reflects light from the sun, which is the point. It does not produce its own light, rather it reflects light from the sun. This other thing we want to point out is in that activity, there's a map, a couple of maps actually, from the United States Geological Survey, the USGS, that you can cut out and actually take it either for a tennis ball. So you take a tennis ball, you cut these out, and you can wrap them around the ball and have your own model of a moon, just like we've got here. So here's one. Here they are wrapped around a tennis ball. There's also another map, I think, that shows differences in elevation on the moon. Yeah, there it is. So that's the difference in elevation with different colors mean different elevations on the moon. So that's a neat little extension. And one thing else I want to come back to real quick that I forgot about, back to that scale model. There's a couple of other things you can use to get to scale. If the moon was a tennis ball, the Earth would be a basketball. So there are two things that are pretty readily available that people have, maybe even bring from home to show kids a difference in size. at least. And the distance on this is 23.5 feet? The distance, so if the moon was a tennis ball and the Earth was the basketball, these would be 23.5 feet away from each other. 23 feet, 6 inches away from each other, and that's the scale, that's the distance scale. Thank you. Okay. All right. I'm done. We'll go through here real quick to make sure. So yeah, here we go. So again, the moon is the biggest and brightest object. It reflects sunlight. It doesn't make its own. The moon reflects less than 10% of the sunlight, so it's very dull and not very bright. And the little activity we did can help illustrate that for kids. All right. Anybody have any questions about any of those activities we just looked at, or anything I might have said? Yeah, I'll have Heather type that in. Northosite. That's the name of the white rock. You said yeah, okay. Those USGS maps. There's links to them in the activities online, in the Marble Moon activity online. In fact, for the Mirror Moon activity, there should be links to it on that activity online. No problem. The 3D Moon Globe link did not work. Okay, well, we'll look into that. Let you know what we find. The link for the Mirror Moon activity, well, that will be with the Marble Moon activities as a whole on the Explore website. There we go. Just like that. Okay. Well, we're ahead a little bit, so I think that's good. All right, I'm going to hand it back over to Eve.
Okay, well, thank you, Andy. It was a great first round of activities there. Hopefully, I've given you some ideas for how to bring this into your programs. Getting the kids to think about what they see in the moon, getting them to understand the real scale, because most people, let's face it, they think that the moon is much bigger than it is compared to the Earth, and they think it's a lot closer. So anything we can do to help them get in their mind the true vast scale that we're dealing with in the solar system is always a great thing. Okay, so for the next part of our webinar, we're actually going to bring on Dr. Neil Cummins, and he's going to be talking to us about the science of what the Earth would be like without the moon. So Dr. Cummins joins us from the University of Maine. He holds degrees in engineering physics, physics, and astrophysics. Lots of physics. Don't run scared, it'll be great. Okay, and he's also a distinguished author. So he's been heavily involved with the authorship of some books entitled Discovering the Universe. And also is a best-selling author for general audiences with books like What If the Moon Didn't Exist, Hazards of Space Travel, and What If the Earth Had Two Moons? So we're very excited to have him with us today. We're going to turn over the presenting privileges to Neil, and excited to see him share the science with us about what would the Earth be like if we didn't have the moon. So Neil, I'm turning it over to you.
Thank you, Eve. I hope you can all hear me. It's a privilege to be here. And what I want to do in the next 20 minutes is to tell you what the Earth would be like without the moon by exploring what the Earth is like with the moon. So what we're going to do is we're going to take a look at our Earth-Moon system as it is now, and then I invite you as we go along here to think about I'm starting my webcam. Apparently it wasn't started. To think about when each of these events occurs in the life of the Earth, what it would be like if they didn't occur. the Start My Webcam isn't responding. There's a button up on the top of my screen that says Start Webcam, and I'm pressing it vigorously. There we go. Wonderful. Okay, everybody. Hi. I hope you can all see me now as well as hear me. Hi, Lynn. Okay, so as I said, what I'm going to do is explore what the Earth is like with the Moon, and in the process, I hope it'll become clear, and I will talk about it, what would have happened if the Moon had never existed. Okay, so let's get started here. And I do apologize, I have to look down every once in a while. I'm going to skip that. I have to look down every once in a while, so if that's distracting, my apologies. Astronomers believe that the Moon formed as a result of a world-class impact between the very young Earth, we don't know exactly when, between the very young Earth and a Mars-sized body. There were lots of those things floating around in the early solar system, and one of them hit the Earth. And this is a computer simulation I hope you can see on your screen. Let me just pull... Oops. There was a... Oh, here we go. Lovely. Aha! This is so cool. Very 21st century. The impact occurred right here, and then the sequence of times go like this after the event. And as a result of that impact, debris was thrown up into orbit, and some of that debris formed our Moon. Now, if you think about it, it's a reasonable question to ask, well, if the Moon had never existed, would the Earth have more mass or less mass than it has today? And obviously some of it went up into space to form the Moon, but the object that hit the Earth, excuse me, it left a lot of its mass in the Earth. So the Earth actually is more massive now than it would have been if the Moon had never formed. So this is our working theory. Here's a cartoon version of the same thing. The impact is here, of course, hits the Earth. And it is likely, we don't know this for sure, but it is likely that that impact was not over the Earth's equator here, but somewhere else. It's just statistically likely. And it is therefore, we think, likely that that impact also tilted the Earth's axis of rotation. This line running through here is the Earth's axis of rotation, and it got tilted by the impact, the Moon formed, and here we are. So that's the model we have of the formation of the Moon. And as I trust you all know, the interaction between the Earth and the Moon is primarily due to gravity. Gravity is the only universally attractive force in nature. Nature has 4 forces as far as we know. The other 3 don't attract everything to everything else. It is only gravity that does that. And of course, if you look at the sky around us and the fact that we're standing on the Earth, it would seem reasonable that gravity is a really strong force. And in fact, gravity is the weakest of the 4 forces in nature. But never mind. Okay, so the formation process is as I described. I'm just sorry, looking at the chats to make sure that people can hear me. Let's take a look at that tilted Earth. This is now still the Earth as it really is. That tilted Earth as a result of the impact in orbit around the Sun. So we have the Sun, here we go, here. And here's the Earth going around it. From our point of view, we always considered the Earth rotating rotating on its axis counterclockwise and orbiting the Sun counterclockwise, because we're making these comments, these statements in the northern hemisphere. So what we do in astronomy is we go above the Earth's North Pole, we look down, and we see that the Earth is going around counterclockwise. So that's why you'll usually, if not always, see the diagrams like this. Okay, so what, you might well ask? Well, the so what is this axis running, oops, my bad, this axis running right down here. That's the north-south pole. As the Earth goes around the Sun, that axis tilted 23.5 degrees compared to being straight up and down, does not change angle. So the 23.5 degree tilt of the Earth's axis right here is the same all the way around the orbit, which is a year. And as a result of that tilt, sometimes the Sun is, well, let me start here. On this particular day, which is called the vernal equinox, the Sun is directly over the Earth's equator. And that day, the vernal equinox, is one of 2 days that there's 12 hours of daylight, 12 hours of darkness everywhere on Earth. Now, as the year goes on, 3 months later, because the tilt of the axis is the same, the Sun is now higher in the sky for us here in the northern hemisphere. It's no longer over the equator. It's over, well, on this day, 23.5 degrees north latitude. And because the Sun is higher in the sky, it is two things. Number one, it's up longer. And number two, it provides more heat and other energy onto the surface, which is why our summers are warmer than 6 months later. Our winters, when we're tilted away from the Sun is over the southern hemisphere here, and we have very short days, and the light from the Sun strikes the Earth up here at an angle, spreads out, is not as hot, and that's why the winter is much colder than the summer. Now you may well ask, well, what about the distance from the Sun? Well, it would seem reasonable that when we're closer to the Sun, it's warmer. Get closer to a fire, it's warmer. And the reality is that when the Earth is closest to the Sun is on or around January 3rd each year. So it's not the distance from the Earth to the Sun that gives the temperature, the seasons. It's the tilt of the Earth's axis caused by that impact we talked about earlier. Okay, so let me now turn to the issue of the Moon's orbit around the Earth. This drawing here on the bottom is one I invite you to look at for a moment. Here's the Moon. It's orbiting around the Earth, but I have to be real careful here. I should tell you, as Eve said, that I have written a few books. And for truth in advertising, oh, and don't believe everything you see on the web. If you Google Amazon, the last time I checked, they said I had written 97 books. Do not believe that. Anyways, the early textbooks that I wrote, way back in the 90s, the early textbooks I wrote, I described the tides, here they are down here, I described the tides incorrectly, mea culpa. However, I've corrected that since then. And so let me very briefly just describe the tides, because this is the crucial thing in understanding what if the Moon didn't exist and never had. Okay? We'll get back to that picture in a minute, and this one too. Whoops, did I? Maybe either I missed this picture or, my goodness. Well, there was a picture I had on here, and it has disappeared. I'll talk us through it. The Moon going around the Earth. You've learned about, or you know about, the phases of the Moon, and the phases of the Moon, from our point of view here on Earth, are caused by the Moon going around the Earth. And in real life, if you ask, well, what causes the tides? Well, what we're told, sort of in the children, what the folks that you're interested in, what children are told is that the force of gravity gets weaker the farther away you go, and that is absolutely true. Okay, and what children are told, and what I wrote in the early days of writing textbooks, is that the force of gravity on the Earth is strongest here, and it gets weaker and weaker. And on the far side, the force of gravity is so weak that it leaves some of the water behind, creating a high tide here and a high tide here. And it turns out that that's not right. Just very briefly, if you imagine two people dancing in a ballroom dancing, holding each other and spinning around and round. As they spin round and round, there is one point between them that, if they were, say, dancing in a straight line down the hall, the two of them spinning together, going as a couple in a straight line, there's one point between them that would be in a nice straight line, and the two in the couple would be moving around each other. Well, that's exactly what the Earth and Moon are doing. And because the Earth is moving while the Moon is moving, it turns out, that imagine if you would, you're on a merry-go-round. You're on the spinning Earth, and which is the merry-go-round, and as it spins, you're being pushed outward. I remember as a kid, I was on the end of a merry-go-round and it was spinning so fast I was thrown off the edge. Well, the Earth going around waltzing with the Moon, the Earth waltzing with the Moon, feels a force due to the waltz that is pushing some of the water away from the Moon. And therefore, the high tide over here is caused by two things. Number one, a weaker force of gravity from the Moon, but also the waltz of the Earth around with the Moon. And the high tide over here is caused primarily by the Moon's gravity pulling on the water. And the last thing you need to know about the tides is that if you were to calculate how high a tide could be by water just being lifted up here or being pushed away over here, the answer is, round numbers, 8 inches. That's it. But in real life, tides are much higher than that. And the reason tides are high is because the gravity of the Moon pulls the water from up here all the way around here, pulls it towards itself, the Moon, or pushes that water from up here all the way around away from the Moon, creating the other high tide. So that's basically how the tides work. And if you have any questions as you're going, please ask them, and they'll buzz me or something. There were tides on the Moon too. When the Moon first formed, as a result of that impact we saw before, it was molten liquid, and as it went around the Earth, it was tides were created on it by the gravity of the Earth pulling on the Moon, combined with the Moon moving around in its orbit. And those tides caused the Moon to be locked into orbit. Remember, you saw the demonstration with the quarter and the penny. And that fact that the Moon is in what's called synchronous rotation. It rotates exactly, here's the red dot here, exactly at the same rate that it orbits the Earth. Synchronous rotation was created by the tides of rock, molten rock on the Moon when it was young. Okay, and one last thing, and then we'll be able to figure out what the Earth would be like without the Moon, is that if you go back to the picture back, here we go, to this picture here, I drew this with those two tides in a straight line to the Moon. That's really not right. In real life, the high tide, let me invite you to look up here, the high tide is not directly lined up with the Moon. The Earth is spinning so fast that it pulls the high tide forward about 10 degrees ahead of the Moon, so that there's water up here, there's more water up here than there is directly in line with the Moon. So what? Well, the so what is that this water has gravity. It has matter, it has gravity, and pulls on the Moon. This water pulls the Moon, and it pulls the Moon in the same direction the Moon is orbiting, as this arrow shows. And the pull of the high tide here, not in a straight line, but the pull of the high tide at a slight angle forward, is pulling the Moon ahead in its orbit. And this is the point where a lot of people, even astronomers, sometimes get it wrong. The high tide pulling the Moon ahead in its orbit as it goes around, it gives the Moon energy, and that causes the Moon to spiral away from the Earth. The Moon is spiraling away from the Earth due to the tidal force from this tide right over here. What is often done wrong, I was on a TV show a few years ago, and another astronomer was describing this, and what this astronomer said was that as the Moon spirals away, it goes faster and faster. That's incorrect. It goes slower and slower in its orbit, but farther and farther away. How do we know this? Well, it turns out that, as you all know, we've been to the moon, and this is a picture of Buzz Aldrin on the moon's surface. And this instrument right here, it's kind of hard to see, but this instrument here is identical in concept to the corner reflectors in your car, the red and orange reflectors, so that when your headlights hit another car, no matter what angle it is, you see that car. Well, we have sent from observatories in Arizona and others laser beams to the moon. These laser beams go up to the moon, they hit this corner reflector, and then the corner reflector sends the laser beam part of the signal back to Earth. And what we do is we time how long it takes to get from here to there and back again. And knowing a very simple equation, velocity equals distance over time, we can determine the distance to the moon using the time it takes the laser beam to get up here and the speed of the light. And what we found since 1969 or so is that the moon is spiraling away from the Earth. So that's how we know this is all true. Okay, so now the big aha thing is, if the moon is spiraling away, then it was closer. And the question then is, in real life, and this is still real life now, the question is how much closer? Well, we don't know exactly how close it was, but in round numbers, about 10 times closer than it is today. When it formed from that collision that you saw early on in my presentation, about 10 times closer. And we can calculate how big the tides were back then, and the answer is the tides were 1,000 times higher than they are today. This is still real life, 1,000 times higher. Furthermore, well, let me just go one picture here for the furthermore. The moon, I said earlier, the moon is getting energy from the Earth, from this high tide pulling it forward in its orbit. Well, that energy comes from somewhere. That energy, because you can't get something for nothing. And that energy comes from the Earth's rotation. The Earth is spinning more slowly today, giving the energy of rotation to the moon so the moon can orbit farther away from us. Moon is spiraling away. Real life now, the Earth is slowing down. How much? About 1,000th of a second per century today. All right. When the moon first formed and it was 1,000 times closer, or when it was 10 times closer, the tides were 1,000 times higher, and the day was about, we don't know exactly, but pretty close to between 5 and 6 hours long. So the young Earth was spinning much faster. It's a 5 or 6 hour day rather than a 24-hour day, and the tides were 1,000 times higher. And those really high tides, of course, pulled the moon very strongly and spiraled it away quickly, relatively quickly, and the Earth's rotation rate slowed down dramatically. There's one thing to talk about back in the day, and this is, and I can't emphasize this enough, this is what really did happen. Those 1,000 times, well, I live here in Maine, and the tides, in round numbers, 10 feet high. So that's, back in the day, if Maine had existed, that would have been 10,000-foot tides, 2 miles high. And those tides went in and out every half a day. We have hopefully you can hear me. My screen just sort of went blank and then I had to reboot it. Back in the day, the high tides going in and out every 3 hours, that's half of a 6 hour day, 2 miles high, in and out every 3 hours. What they did, those high tides, is put a huge amount of the minerals on the young continent surface back into the oceans. So, real life, the oceans were salted, if you will, filled with minerals because of the tremendous tides that existed when the moon was very young, the Earth-Moon system was very young. And that is the primordial soup in which life first formed. So now, let's take the moon away. The moon had never existed. What would the Earth be like? And hopefully, as I've gone through this, you've been thinking about it. Well, there would have never been this impact we talked about, and the impact tilted the Earth's axis, created the seasons. So, if the moon had never existed, there would be no seasons as we know them today. It turns out that in 1994, calculations were done that discovered that if there was no moon, and the Earth was spinning fast, 6-hour day, 7-hour day, the axis of rotation, north-south, would be unstable. So if this is the north-south axis before the impact that tilted it over, if this is the axis as the Earth goes around the sun without the tilt, okay, if there had never been a moon, that axis would wander like this all over the place. And that would create incredibly complex and sometimes unpredictable seasons over thousands and hundreds of thousands of years. So if the moon had never existed, there would not have been seasons originally, but as the Earth tilted strangely, and Mars may be doing this, by the way, because it does not have a big moon, the seasons could have been dramatically different, dramatically different than they are today. So that's number one. Number two, the tides. Well, the tides we have today, two-thirds of the tides are caused by the moon. The other third of the tides today, real life, caused by the sun. So if the moon had never existed, the tides today on the Earth and throughout its life would have been 1/3 as high as they presently are. They never would have been 1,000 times higher. There never would have been the monster tides to strip the land and fill the oceans with a primordial soup. And therefore, it is very likely that the evolution of life would have been greatly delayed until rivers ran into the ocean, probably hundreds of millions of years longer time scales, before the oceans would have had enough mineral for life to form and evolve in it. So that's another effect of what if there was no moon? What if the moon didn't exist? The lack of a moon would, of course, have effects today in the kinds of things we do in our everyday lives. As Eve said, I think it was Eve said earlier, there would be no concept of a month because there would be no cycle of phases. Interestingly, for our sociology, the moon was a target that President Kennedy could aim for when we started the space race. We could and we can get there easily. If the moon had never existed, there would have been no easy target to go to. Getting to Mars, even today, is very, very hard. I write about that in my book, The Hazards of Space Travel. So, besides the physical changes, the day would still be much longer. The seasons would be wildly weird. The tilt of the Earth's axis would be very unpredictable and very erratic. When humans or life forms did evolve on the Earth without the moon, they would not have had that kind of target. It would have been harder for them to take their first big steps into space. In case you're interested, since you are librarians, many of you I understand, the book I wrote, What If the Moon Didn't Exist, which has been out of print for a long time, is coming back into print next month. Also, the misconceptions that were being discussed earlier, fascinating stuff. There's a book called Heavenly Errors, all about misconceptions in astronomy and astronomy alone, and a website called Heavenly Errors, in which something like nearly 2,000 astronomy misconceptions are posted, some with hot links to the correct science and some without. And so I invite you, besides the great work that Phil Plait is doing, to take a look at the Heavenly Errors material. And I think it's pretty good because I wrote it. So anyways, at this point, let me stop since I've talked for the 20 minutes or so that they've requested. And if you have questions, I would be absolutely delighted to answer them. The question from, let's see, from Jane: the larger the moon a planet has, the more gravitational pull on that moon. The answer is yes. And if a larger, more massive moon, Jane, was at the same distance as our moon, the force of gravity from it would be greater. It would orbit more rapidly. The day would be shorter. I said that wrong. The cyclophases, the month would be shorter, and the tides on that planet with a more massive moon would be higher than they are today. Lynn asks, Venus and Mercury have no moons. Do they wobble wildly in their axis? Well, Venus is very... The short answer for your question, Lynn, is no. And the reason is because, number one, Venus was knocked over... Well, let me back up. Here's my... If we consider this the North Pole of the Earth, it's tilted, as we know in real life, 23.5 degrees compared to its orbit around the Sun. Okay? A tilt like this is not unreasonable given the impact that happened. Venus, however, is tilted like that, almost directly upside down with its what we would call North Pole here. And it is rotating very slowly. And that slow rotation makes it so that it probably does not wobble nearly as much, or almost, that slow rotation makes it so it does not wobble nearly as much as it would if it was spinning faster. And why is it spinning so slowly? We think that the impact that knocked Venus upside down in its orbit, its rotation on its axis, probably also slowed it down tremendously. Mercury is spinning, rotating very, 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 very slowly compared to anything else. And the reason that is that the gravitational pull of the Sun has affected the rotation rate of Mercury, slowing it down. Mercury is not in synchronous rotation with the same side facing the Sun all the time, as the Moon is with the Earth. Mercury is not like that, but it's close. It's close. For every 2 orbits around the Sun, Mercury rotates 3 times. And that slow rotation of Mercury prevents it from tilting wildly. The Sun keeps it trapped, if you will. So the answer for Venus and Mercury is no. Connie asks, what is the title coming back? Oh, the title coming back into print. Well, thank you for asking. It's called What If the Moon Didn't Exist? Okay, I would be absolutely happy to answer any other questions. I hope I've stayed within the time limits that Eve set out. Heather asks to confirm, what if the moon didn't exist? Yes, that's exactly the title. That's exactly the title. Is there anything else people want to know about the real-life Earth-Moon system? Oh, by the way, there are samples of the Moon and Mars that you can actually buy, and they are legitimate. And they're not stolen from NASA or anything else like that. They're available because there are pieces of the Moon and pieces of Mars that have been splashed off the surfaces of those bodies by impacts and fallen to Earth as meteorites. And the meteorites that have been identified as coming from Mars, coming from the Moon, have been broken up into little tiny pieces and sold legitimately over the, in the kinds of meetings that astronomers go to, for example. So you can actually buy a little tiny piece of the Moon if you want. question is, how are they identified as coming from Mars and the Moon? Excellent question. What the scientists have done with these meteorites is to determine their chemistry, which a friend of mine in geology does this on a regular basis, and apparently you can determine the chemistry of something like that in a matter of minutes now with our technology. And those meteorites are then compared to, well, the ones from the Moon, they're compared to the moon rocks that have been brought back by the astronauts. And if they are the same, then it is considered a match, and that meteorite is considered to have come from the Moon. For Mars, there are clays in the soil and other things that, other properties of the soil, not soil, bedward, the layers, the top layers of Mars that came with the presence of water. We don't know the nature, the qualities of that water, but it laid down layers on Mars. And when some of that debris was knocked off and came to the Earth, the analysis of that debris showing the clays that only, as far as we know, could only have come from Mars, those meteorites are then deemed to have come from Mars. Can you give an example of what the Earth would be like if we had two moons? Aha! Yeah, let me just, let's imagine, if you will, the moon where it is today and another moon half as far away. Is it possible to arrange? The answer is yes. I write about this in another book, What If the Earth Had Two Moons? But the punchline is this. If that system exists, or could exist to start with, then what happens is that the tides from the Earth have a stronger effect. The tides from the Earth have a stronger effect on the closer moon, because it's closer, stronger gravity, than the tides from the Earth have on the farther moon. And therefore, the Earth spinning pulls the closer moon more than it pulls the farther moon. Therefore, the closer moon spirals outward. Remember, the high tide pulls on the moon forward in its orbit. The high tide would pull the closer moon out faster than it pulls the farther moon. And as a result, if the Earth had two moons, the inner moon would spiral out faster than the farther moon, and eventually they would collide, and we would only have one moon. It's a no-win situation. You can't have two seriously large moons like ours orbiting around a world like the Earth and not eventually have them collide. With Saturn and Jupiter having multiple large moons, it's a different set of phenomena. There are effects called resonances that prevent the moons from getting away from their present orbits. That would not happen with the Earth and two moons. I've heard that the peridots found on Earth all come from the moon. Any truth to this? Good question. I don't know the answer, so I honestly can't say. If I do find out, I'll pass that along, and Eve can perhaps let you know. I see 3 of your books in our system. Looking forward to reading them. Well, thank you. Good information if the moon did not exist. Very kind. Thank you so much. I appreciate that. Is there anything else? Oh, there's one other thing that comes to mind, if I have just 30 seconds more. Real life, as you see on your screen, I hope with these pictures here, the moon really is spiraling away. And another thing that many people get wrong, including some astronomers who talk on television, they'll say that as the moon spirals away, it keeps on getting farther and farther, and eventually it will leave the Earth. That is incorrect. As the moon spirals away, its orbital period, the month, gets longer. Perhaps, I trust that's not a surprise. The Earth is slowing down. When the Earth is rotating on its axis at the same rate that the moon is going around, so the Earth is rotating, the moon is orbiting at the same rate, the moon will never go out any further, because the high tide will finally be in a straight line with it, can't pull it forward because it's in a straight line, they're orbiting and rotating at the same rate, then the moon will be locked in orbit at that distance forever. It's going to take about 50 billion with a B years, but in about 10 billion with a B years, the sun is going to explode, so who cares? Is the Earth and Moon relationship so unique because of the water on Earth or other factors? Interesting question, which I've never been asked before. The water on the Earth, large-scale oceans on the Earth, the oceans are the primary cause of the interaction, the tidal interaction between the Earth and Moon. Absolutely, without a doubt. There is some very, very, very minor tidal effect from the Moon on the Earth's atmosphere, and there is a very, very tiny tidal effect of the Moon on the physical Earth. In other words, there are tides on the Earth, but they're only at most a few inches. So the vast, vast majority of the interaction between the Earth and Moon and their interplay of spiraling away and slowing down is due, indeed, to the oceans. Peridot is a gem form of the mineral olivine, and certainly olivine is one of the most common minerals on Earth's mantle. Is found in many locations. Absolutely. What Heather says, thank you, Heather. And I believe that olivine is found. No, I'm not sure whether olivine is found in moon rocks. I have the vaguest recollection that it is, but I could be wrong about that. Vanessa, I'm sorry that you lost the audio, but then, of course, you can't hear me if you have. Yes, very good. Thank you, Heather, for confirming that the olivine is indeed found in moon rocks. But from what she said in the comment above, the peridot found on Earth is not all from the moon. If it's found in a lot of Earth rocks, it's processed. Olivine is processed inside the Earth and comes up with magma as the magma moves towards the surface and becomes lava. All right. Is there anything else I can share with you? Back on the audio. Okay. Hi, Eve.
Hi, Neil. I'm back. Thank you very much for that discussion. I think we're at a good point to maybe wrap that, and we'll continue on if that's okay with you.
By all means.
If you think of if the participants, if you think of any other questions as we're moving along, continue to put them in the chat box. We will continue to address your questions as they fit in with our discussions, and towards the end we will address anything that we haven't gotten to yet to our best of our ability. So please continue to use that, and as I'm seeing in the chat box, thank you very much, Neil. We really appreciate you taking the time to come and be with us today, and it definitely gives us a lot to think about as far as what the Earth would be like without the moon, and how much it really influences us here on the Earth. So thank you, and we're going to move on now to some more activities.
Thanks, Eve. Thanks, everybody.
Okay, so we do have a few more activities that we want to go through with you today. And these are going to relate to some of the things we've just been discussing with Neil. So we have this nice science background now coming into some of these. And you know, he likened the Earth and the Moon's interaction as a dance. And so the first activity we're going to look at actually deals with tides, and it's called the Dance of the Moon in the Ocean. And so this idea, again, of how the Earth and the Moon are kind of dancing together, and we can see this through our tides to a certain degree. So this is an activity where the kids will actually be modeling how the tides are caused and how they change over time. You'll notice here that we have a few pictures. This is the Bay of Fundy at high tide and low tide, and this is within the module, so these are pictures that you'll be able to download, print, and use. But to get everybody thinking about what we're seeing here, and how the ocean level changes over time. I don't know how many of you are familiar with the ocean. How many of you visited the beach and actually watched how the water changes over the course of a day? But as we've just been going through, the moon's gravitation is really what is causing our ocean levels to rise and fall twice a day in 2 high tides and 2 low tides. So with the activity I'm going to explain to you today and show you some video clips on, we're going to show you a way to have the kids walk through this, through the dance of the moon and the oceans. Before I move on, I do want to mention that this is an activity that is really only appropriate for children ages 10 to 13 or older. Even adults actually could benefit pretty well from this. But it is important not to do it with children under the age of 10. And the reason for that is that in this model, the children are going to be representing the Earth or the ocean or the moon. And we found that children under the age of 10 often have a hard time conceptualizing the fact that they're standing on the Earth, but then also modeling it themselves. And they aren't really able to form the proper model in their minds about how this works. So this is more appropriate for the older children in your programs. So the dance of the moon and the oceans. You can see here we have a picture we've taken. There's Andy getting to play a role. And so we've set this up with some of our coworkers. And this actually will take 6 children to help model. It's a great time to talk with them about why models are important. Of course, scientists use models to help demonstrate objects or processes and how they work in order to understand them better. So here we're going to be using a model to demonstrate why we have the tides here on Earth with the oceans. So you'll notice in the picture we have 4 people dressed in blue shirts that are representing the Earth ocean. In the middle of them is a person dressed in a brown shirt representing the solid Earth. And then down the corner there with his lovely shot there. Love it, Andy. We have Andy, and in this shot he's wearing the yellow shirt, but you'll see him in just a moment in a gray shirt. So he'll actually be representing both the sun and the moon. I'm sure a very distinguished honor to be able to play both those roles. So each of these people will be one of the dancers and have a role within this activity. And I guess, one other thing to keep in mind and point out to them, since this is a model, models in general, in order to model a specific process well, sometimes have to make other simplifications. And so something to point out to them is obviously this model is not to scale. The size of our Earth, ocean, and moon and sun are not what they should be in relationship to each other. And the distance is definitely not to scale either. And thinking about that distance, we're comparing this to a dance. And for us as people, when we dance, obviously we're generally touching each other or in pretty close contact when we're dancing together. But that's largely because we don't have very much mass, right? My gravitational pull isn't very great because I'm not too massive, I hope. And so if I choose to dance with someone like Andy, my gravitation's not going to have a large effect on him. But when we talk about things like planets and moons and the sun, we're dealing with things with a lot of mass. And because of that, they are able to influence each other over very large distances because of their much larger gravitational pull. Okay, so going into our activity and our modeling. Here we have, actually I'm going to back it up for just a second. I want you to notice the starting position of our different dancers, so to speak. Notice that they're all fairly tightly together, and this would be your starting position. So the next slide I'm going to show you is another way to do a starting position. That is perfectly fine as well. You'll notice they're also holding a blue string between the different people representing the ocean. That can help you to see kind of the shape of the ocean around the Earth as we go through this, which can be a useful tool with the children as well. You notice Andy is now in his gray shirt. He is representing the moon for us. So right now, all of our dancers are facing the moon. And so in order to do this activity, what you'll have them do is the person representing the ocean, who is the closest to the moon, is going to take 3 steps towards the moon. After they move, we will have the people in the middle. We'll have the solid Earth and the two oceans next to the solid Earth take 2 steps towards the moon. And then finally, in the last phase, we'll have the remaining person representing the ocean, the one that's farthest from the moon, take just 1 step towards the moon. And real quick, I'm going to ask you, why do you think we're having the different dancers, so to speak, take a different number of steps? I'll give you a moment to use the chat box. I see a few typings. Let's see what we have here. Gravitational pull, distance from the moon. I'm seeing a lot of gravitational pull. And actually, that's exactly what I want you to be thinking about. You know, Neil gave us a very detailed scientific explanation for the tides. And that was really intended for us as adults. As you mentioned, though, as we teach this to children, especially in the younger age groups, a lot of times we focus more on the strength of the gravitational pull and its effects on the Earth and its tides. And so really that's what this activity is focusing on. And so, as we'll notice, the person closest to the moon is being pulled the most. It's feeling that pull of the moon the strongest, and so it takes more steps. And thinking about that, I want you to just ponder for a moment, what would that do to the shape of the string connecting all the people representing the ocean? You know, starting out, we started out pretty circular. How would that change after they have made their steps? Again, go ahead and use the chat box. I'll give you just a moment. What shape do you think the ocean would be making now, as opposed to when we started? I'm seeing elliptical, oval, and that's exactly right. It would be more of an ellipse or an oval. And so now we're seeing that that ocean is being pulled into a different shape. And then we can start to think about what that means. Where do we have high tide? Where do we have low tide? And so next what I'm going to do is I'm going to have Romero bring up a video clip. It's very short. It's just going to show our dancers in this instance going through this process. And you'll see it in action. So here we go. They're all together in the starting position. We have our first dancer taking 3 steps. We now have the 3 middle dancers taking 2 steps. And then finally, the remaining person taking 1. And even from this angle, you can see that kind of elliptical or oval shape that you were all telling me we would have. So bravo, excellent. That is exactly what we find as we're coming through this. So let me advance our slide. And we can show this just via some symbols. But here we go. And as you'll see, we can now locate after their movement where we would expect to find our high tide and our low tide. So again, similar to what you found with the science presentation that Neil was talking about, we find in fact that the high tide will be located on the side closest to the moon and the side furthest away from the moon. And we find the low tides on the sides that would be next to our solid Earth, or 90 degrees to that. So thinking about a person representing the solid Earth in the center of this dance, the next thing we like to point out and have people think about as they're modeling this is what part of their body represents which part of the tides. So what body parts on our beautiful helper in the picture would represent high tide? And let's keep it clean. Be your front or back or side. I hear chest. Sometimes we'll say face, right? So the front of her face would be one of the high tides. Yep, high tide on the face and the back, right? So exactly right. And then thinking of the low tide, looking at our person then, if you're standing facing the moon and we're set up in this orientation, then each of your arms should be pointed towards a low tide. Okay, so we've gone through kind of an initial modeling of what causes the tides and the fact that it's the moon's gravitational pull. Of course, like Neil pointed out, the Earth and the moon aren't sitting still. So the next part in this activity is to add in some motion. And in this case, we're not going to have the moon move because, relative to the Earth's motion, it's much slower. And speaking of tides, really what we're interested in is the Earth's rotation. So next we're going to have that rotation modeled by the person playing the solid Earth. So in this next set, and we'll have a video for this in just a moment, we'll have the person representing the Earth spin in a circle counterclockwise, because of course the Earth spins counterclockwise, so make sure to have that child spin to their left, and have them complete one turn to represent one day. And as they're doing that, they can think about what types of tides they're seeing within the course of one day. So we're going to go ahead and play that video for you. We can see our lovely Earth turning in the video. In this case, we had her turn a couple of times just to demonstrate it for you. But as you're doing this with the children, it's good to have them complete one spin, think about it, and then you can have them do another one. You could stop them partway through their spin and have them, again, using their body parts, think about what type of tide they're seeing. In the picture we have up right now, our Earth is actually facing kind of halfway between the two people representing the ocean. It's kind of hard to see in the picture, but that's where she was facing. And so thinking about that, where would her high tide be? Which arm would be her high tide, or which shoulder? Go ahead and use the chat box. I'll give you just a moment. Okay, so the one closer to the moon. Well, in this case, okay, I see a left shoulder. Well, if we think about this, remember the moon hasn't moved. We kept that in its same place. And she's facing between these two. And if you were her in that moment, actually your right shoulder would be towards the person on the ocean who is furthest from the moon, which remember we said would be one of the high tide positions. So her right shoulder would be near high tide. Her left shoulder would then be near the low tide. So again, as we're thinking about this, you can slowly spin and think about how that is changing over time. And then hopefully the connection will be made that over the course of one day, you should see two high tides and two low tides that are being caused by the pull, the gravitational pull of the moon. Okay, so one more thing we want to think about with this activity then, and that's the sun. And, what if there was no moon? So the next part of this activity is taking away the moon. So you see Andy Swick's shirts here. He's no longer the moon, he's been promoted to the sun. And he's wearing his yellow shirt. So the sun does have a gravitational pull on the Earth, obviously, but it actually only contributes about 1/3 of the total height of our tides. So thinking about that, if there was no moon, our tides would be about 1/3 of the height that they are today. But we would still have tides. They would just be much smaller. So in our modeling, again, we can walk through this dance, and this time using the sun. We have no moon. And we're going to adjust our steps. So thinking about this, for the original model with the moon, we had the front person, the person closest to the moon, take 3 steps. The next group took 2 steps, and then the person furthest away took 1. How many steps do you think we should have our front person, the person closest to the sun, make this time? Go ahead and give me a chat box. I see 1. Yes, easy math, right? We made it easy for you. So we would be able to reduce this so that the person would, if it was going to be 1/3 of the height, it would be 1 step. Now in this case, we've adjusted it in a little bit different way. What we've done actually is the person in front who will be walking closest to the sun will take one large step towards the sun. Then the person playing the ocean, the solid earth, and another ocean will take one normal step. And then finally, the person furthest from the sun, representing the ocean, will take only a small step. So making that adjustment as we move forward. So again, we have a video clip demonstrating this. We'll go ahead and play that briefly for you. Here's one large step, one normal step, and one small step. So again, if they're holding that string between them, you could also look at the shape that's making in the ocean. The difference between the tides is not going to be as great. Your oval, your ellipse is not going to be quite as pronounced. So something to think about as you're conducting that modeling. So, wrapping it up. What would the tides be like, or what would the Earth be like as far as tides without the moon? Well, we'd still have our tides, but they would be smaller and not nearly so high for us. We have a question, let's see. So does this mean that the new and full moon, the tides will be a third higher? At certain times of the year, you're correct, the alignments are in such a way that we get additional effect to our tides so that we see a larger high tide or a lower low tide. So that can happen, you're right, and it's based on the positions of the Earth, Moon, and the Sun. Okay, and as a wrap-up for this then, of course you can wrap up with the kids getting into think about Earth without the moon, what that would do for us as far as the tides, and as a more practical thought, how would that affect life? If you go down to the ocean side and you watch the tide go out, you'll notice lots of little creatures in the sand. How would that affect them? So, you know, it's more than just the level of the water. There would be effects on life and on us as people as well. So this comic book page that goes along with it, they are able to capture that and put their ideas in about what they think it would be like as far as tides if there was no moon. Okay, so if there are any other questions about that activity, I'll give you a moment if there is. But if there's not, we're going to move on to another modeling activity that I think you will be really excited about. It's very powerful. And I'm not seeing any typing or any other questions, so I'm going to go ahead and move on. If you think of something, feel free to add it in there. We'll get to it as soon as we're able to. Okay, so the next activity from Marble Moon that we wanted to go over with you today is called A Dance Under the Sun. And this activity is teaching about lunar phases and why we have them. So this is an outdoor activity. You want to make sure that you have good weather that day. You'll have to get out. You have to be able to see the sun and also a daytime moon. So in order to pick a time, there are plenty of great resources where you can look up your moonrise and moonset times, so you'd be able to find out when a moon would be visible in your daytime sky so that you would be able to do this. I believe sunrisesunset.org has that information, and those resources are listed within the activity write-up, so you can find them there. It is important to note that this activity must be done individually. Each person has to do it themselves, because it really, as we're doing this, our head is going to represent the Earth. You can't let somebody else's head represent it for you. You can't demonstrate this for them. They're going to have to experience it themselves for it to be done correctly. So something to keep in mind. And one other thing I just want to point out is, again, this is an activity that's going to be better for the older children. So ages 10 and older. Again, you don't want to go younger than that, because if their head is representing the Earth and they're standing on the Earth, they sometimes can't model that in their heads well. And so they create two separate Earths, and they don't really understand the concepts as we want them to. So again, just keep in mind that this is more appropriate for the older children in your programs. And this activity is really important because a lot of people don't really understand what causes the moon phases. Even a lot of adults, and you ask them, a lot of times they think it's a shadow. And it's the Earth's shadow causing our moon's phases, which isn't true. That's not really what's causing them. So this activity is extremely powerful, is getting people to model it themselves and really help them to see what it is that causes moon phases. So for this activity, we're going to use a nice styrofoam ball, and I've stuck a popsicle stick through it there so it's easy to hold. And you would take these outside with the kids and use this for your model. So again, get them thinking from the beginning about their model. I can point out again, the scale is not correct here. The size of our Earth and Moon are not what they should be. And of course their distance. I'm only going to be able to put this arm length away. And so, my moon is not going to be as far away from my Earth as it should be. But it's still going to be effective for demonstrating why we have the moon phases. So thinking back to what you did with Andy with the mirror moon, we've already kind of discussed that the moon doesn't create its own light. It reflects the light of the sun. And so this illumination from the sun is what causes our phases. But what a lot of people don't tend to understand is that it's actually our perspective that is causing that to change over the course of a month. So for this activity, we'll get outside. Hopefully it's a beautiful day where you're at. That'll take a little bit of planning on your part. And we'll use our ball to represent the lunar phases. So what you're going to ask the children to do first is just to experiment. Have them hold their ball out at arm's length and just kind of move around and kind of take a peek at the moon that will be up in your sky at this time, and ask them to try to recreate on their ball what they see on the real moon as far as how it looks. So the pattern that they see on the real moon, the phase. And as they move around and attempt to do this, eventually what they should find is that they're able to recreate this same phase as the current moon that is in your sky when they hold their model moon in the same direction or towards where they see the moon. So in this case, the sun will be lighting it from the same way that we're seeing with that. And I guess we could demonstrate this really quickly for you, even though your perspective will not be correct, of course. But we've dimmed one of our lights. And if I move over here, you can see, at this point, part of the moon is dimmed for you. I guess to you, it probably looks like a waxing gibbous. If I move, the amount that we see lit up will change. Actually, if I turn it this way, I get in the camera, I'm going backwards, sorry. The amount of that we see will change. And so same thing will happen outdoors, and they'll be able to recreate the different phases of the moon. So once they've identified the phase that is up in the sky at that time, then what you can do is turn them loose and let them play around and see what other phases they can make. And over time, what they'll discover is that they can make all of the phases by turning and changing their position. You can encourage them to start out facing the sun with their ball high. When I do that, I'm sticking it towards the light here. I can't see the lit up part of my moon. And this is probably what I'd call a new moon then. But as I turn to my left, I can start to see more and more of my moon being illuminated by the sun, and my phase will change. So I'll be able to make a crescent moon. I'll be able to make a first quarter moon. I'll be able to make a full moon. And they'll get to learn where the moon is positioned relative to the Earth and sun in order to do that. So to help them understand that it's not my shadow causing a moon phase. It's where the moon is in its orbit around the Earth relative to the Earth and sun. Quick question, this might be a trick question. How much of the moon is illuminated by the sun at any given time? Go ahead and use the chat box. Seeing a lot of halves, yes. So the thing to remember here is that half the moon is being lit up by the sun at all times, but depending on where the moon is in its orbit around us, we don't necessarily see the full portion that's being lit up. So keeping that in mind. Now, if you have advanced students or children in your group, the next thing you can do with this activity then, and this is in the write-up, is have them start to predict what phase the moon is going to be in another day or two or a week from now. They can start to figure out the pattern and the order that it goes in and how we could recreate that with our model, where the moon will be positioned relative to the Earth and the sun in order to see that phase. So again, this is a very powerful activity. In the activity write-up, there is an alternative in case your weather does not cooperate. You can recreate this similar type of modeling with a black light and golf balls. So definitely try that out, experiment with it. You will be amazed, I promise. So again, just kind of showing how my coworker was demonstrating this. We got the camera right behind her, and she was recreating the phase that was in the sky. And one thing you'll discover as you do this, in order to create the proper pattern of phases, you'll have to turn counterclockwise. And of course, that's because the moon is orbiting the Earth in a counterclockwise way. Okay, and so, I'm sorry, I got a little ahead there. And so with that, unless there are any questions, I have one more activity I want to show you. It'll be fairly quick, but you will need your Oreos if you want to grab those quickly if you gather the goods for our webinar today. And I'm not seeing too many questions in the chat box, so we'll go ahead and do this one with you. Okay, so the last lunar phase activity we wanted to talk about today is called Lunar Phases, and it's an edible activity, which are always very popular and a lot of fun for everyone. And in this activity, the children will recreate the pattern of the lunar phases. So generally, this is an activity that you might want to do at the beginning of teaching lunar phases because it teaches them the different shapes that it goes through. You can teach them the names for each, and they can learn that pattern. I will say this is absolutely appropriate for younger children in your programs. Unlike the other modeling activities we were looking at, this one is about pattern recognition, so it will be perfectly fine for the younger people in your program. So we're going to switch over to our other camera, and if you have printed off this sheet, you can pull it out, and along with your Oreos. For this activity, the children will be given 6 Oreo cookies, which they will carefully twist apart. And they'll use the frosting then with a knife or a spoon or whatever you choose to recreate the shapes of the phases of the moon. And so they can use the sheet. You can have them create each separate phase and place it on top of the matching spot on the worksheet, which Andy is going to do for us right now. So of course, one side with no frosting is our new moon. We created a waxing crescent moon. And we'll move towards a first quarter moon. But you can work through the different phases. And he'll continue to set those on there for us. And while you're doing this with the children, I would encourage you to read stories to them about the moon's influence. Celebrate it. There's lots of poems, there's songs, and there's actually some really nice sayings within our activity write-up that you can sing with them to common songs that we know. So check those out. I've added one more video link here I just want to point out to you, and perhaps I can have Heather copy and paste that into the chat box. But if you haven't seen it, check out Dr. Lee's Phases of the Moon on YouTube. This is a really nice song. It gets in your head that teaches the phases of the moon, as well as some of the other science that goes with it in a very nice way. It's put to a pretty familiar rap song that the kids will recognize most likely. And again, finding a cultural connection for them to help with this activity. So finally, the activity, or the comic book page that goes along with this, is them making their own poem, so the moon in their own words, using lunar phrases, and it's a great way to wrap up that lovely, yummy activity. So if you have your Oreos, please go ahead and eat them now. I encourage you to enjoy them as you would in your programs with the children. And just a couple of parting thoughts then with our activities. Without the moon, there would be no nearby moon to study through telescopes, of course. There'd be no moonlight for nighttime illumination, which most of us tend to enjoy, I think. And it could also have some impacts on animals. And there would be no stories, legends, songs, poetry, or music about it, or fun things like werewolves, as you see. Of course, we couldn't make up those fantastic characters without the inspiration of the moon. So, inspiration of the moon. Exploration, yes. Andy's correcting me. So thinking about that, great way to think about what are your favorite moon connections. I'm sure there are songs that you can think about or poetry that would connect with this. Well, that brings us to the conclusion of the activities that we're going to cover today. I hope that you've enjoyed them. I hope that you'll find them useful in your programs. Here again, we've put the Marvel Moon link. This is where you'll find them. You'll find also a nice science background information for you. You'll also find resources that will help you in conducting these. And just as a reminder of what we've done today, we've looked at cultural stories of what you see in the moon. You looked at moon mythbusters. What are some true and false things about the moon, and how can we sort those out and use our logic? We looked at the size and the distance, how far away the moon is and the sun, and their sizes compared to each other. We looked at some misconceptions as far as what really causes us to see the light of the moon. It's not from within the moon itself, but it's reflection from the sun. And we modeled some kind of complex processes that, in a nice way, to help the children understand how these things work as far as the tides and the lunar phases. And of course, compiling all this into your customizable comic book is another great resource that they enjoy to take home with them, and hopefully they can share that with their family and their friends. Okay, so just a couple last activities that I just want to mention briefly and point you towards. I know Andy mentioned earlier with one of the activities he was discussing, I believe it was with What We See in the Moon, with the pictures, that there's an activity within the module called Moon in Action, which is a nighttime viewing activity. And we highly encourage you to look into your local astronomy clubs or societies. They are often very happy to bring telescopes and help partner on these sorts of things if you have a suitable place to hold something like that. And we realize that not all of you do, so whatever makes sense for your site. Also, there's an activity called My Take on the Moon. Sorry if the word got cut off a little bit there. But this is an activity, and there's a template for this within the module, where the children get to complete their activities with creating their own zine, which you could add to the library collection if you want. I have an example of this. Maybe I'll have Andy show it briefly under our other camera for you. But a zine is just a small little 8-panel story made from one piece of normal size paper, 8.5 by 11, that's folded up. And so the printable template is there for that. All you have to do is print them, and then let the kids go wild. They can create their own story about what would the Earth be like if there was no moon. And so this is an example that we have. You can flip open the page a bit, and it just tells, you know, kind of maybe one big idea per page, and some nice illustration and creativity to go along with it. Okay, so let's switch back, and I want to thank all of you for being with us today. I hope this information has been useful to you, and will continue to be. Before we move into our interactive programming discussion, I just wanted to see if there are any other questions out there about the activities or about anything else we've done up to this point. And so I'm going to give you just a moment to use the chat box in case you have a question. Me and Andy are happy to address any other questions that you have. Okay. I'm not seeing any questions at this point. I'm just seeing a lot of thank yous, which is great. I'm so happy that you've gotten a lot out of this so far. And I'm glad you enjoyed the food as well. I wish I had some Oreos to enjoy. Oh wait, we do. I just can't eat them yet. It wouldn't look good probably on set with Oreos in my teeth, right? Okay, well, let's move on to the last part of our webinar there, and that is the interactive programming discussion. So I'm going to have Ramiro open up the mics. We're going to give you a chance to tell us what you think about these materials. How can you use these in your programming? Do you have some plans in mind already for what you might do with these? And if you do, could you please share them with us now? You can either do this via the chat box, or you can do it with your microphone. If you are going to use the microphone, you'll probably have to go up there and click on the arrow next to it and enable your microphone first. And again, next to that, remember the person with their hand up icon. If you click next to that, you can also use the raise your hand function, so we can try to give everybody a turn and make sure that nobody's talking over anyone else. So let's see what we have coming in here. I just looked over and saw something about International Observe the Moon Night, so that's excellent. Of course, that's coming up pretty quick here, and I don't want to dig into that too much because we are going to talk to you really quick about that right at the end. Let's see, what else do we have? Possible family program at the library, excellent. Are there any activities in particular that you are excited about, that you feel strongly that you're going to go out there and share and use in your programming? I see we have a weekly Saturday Science Lab. We have one on the moon, and perhaps we'll make it a family day. I think that is an excellent idea. Get the whole family involved. We have a weekly story time for elementary schoolers, and we are doing Moon Month throughout October, ending in Halloween. Howling at the moon. And hey, maybe you can use that Earth's Brightest Neighbor activity with the giant moon bag for the scale. That would be a fitting activity for Halloween. We did a grades 3 through 5 book discussion on the first book in the Guardians of Ga'Hoole program last year. We dissected owl pellets. Let's see, the moon activities would have been a good extension. I'll look for a way to tie them to a different book group selection. So sounds like maybe able to tie that into some of your book groups as well. Excellent. We'll have our young kid, let's see, sorry it's going fast. Kish here says that we will have our young kids demo the Dance of the Moon in Oceans along with story time. I really love that idea. That'd be a nice addition to your story time and add a little activity. Jane says we used the Family Space Day stations last year for INOM. It was a big hit, especially when the kids created the Lunar Living Station. Good. I'm guessing you're referring to the Family Space Days website that we have through our LPI education page. And of course there are lots of great resources there that would be good for use for kids a little bit younger, say 5 to 8 years old. Any other thoughts or plans? I know summer reading programs are listed for the next coming years. I believe 2013 is Dig Deeper and Beneath the Surface. And I believe 2014 is Science. Awesome. So perhaps you'll find a way to use these with those as well. See, Lynn says, do you know where the Moon-Earth relationship fits into the Common Core standards to be rolled out? What grade level do science programs for class visits? An excellent question, which I'm not sure I can answer off the top of my head. Andy, do you have any idea?
It's before high school.
We know it's before high school. We're not real sure where that fits. I will mention that each of these activities is tied to current national standards, and so if you go into the activity write-ups, you'll find all that information there. So I apologize, I can't give you a more detailed answer, but if you check online on our website with those activities, you should find what you're looking for. Of course, how that relates to new standards coming out, unfortunately, we haven't made those connections yet. Okay, I see book group, Where the Mountain Meets the Moon by Grace Lynn is one of my favorite I choose. Vanessa, I like that. I haven't seen that book, but that sounds like a really good tie-in to what we've been talking about. Jane says, we already have our INOM plan for this year, but we'll definitely prepare what was learned today for next year or throughout the coming year. So, excellent. We're happy to hear that you find these useful, and hope that you'll have successful programs in the coming year. Please keep in touch with us and let us know how it goes. We would like to hear more about how these are working for you actually within your programs. So feel free to contact us with that information. With that, I was just going to check with Andy. Is there anything else that we wanted to pass along to them? No, I think we're good. I just noticed that Erin mentioned that they are now going to make some last-minute changes to their INOM to include Moon Mythbusters. So, excellent, thank you. One thing I will mention to you, Moon Mythbusters is going through a little bit of an update soon, as will all of these materials actually. I've been working to update them. So within the next couple of months, I'll be sending out an email letting you know when that happens. And one of the changes will be within Moon Mythbusters, where there'll be an option for the kids to create their own skits. And there can be a team that will be the true blue moon and a team that could be the far out far side. It could give you a fun way to tie those things together and let them perform it in more of a Mythbusters TV show type way. So I think with that, I'm going to close down our interactive discussion for now. Although, as always, if you have something else that you think of or you want to share later, please feel free to email me or contact me, and I'll be happy to pass that along with the group. Well, before we let you go today, there's just a couple more last things I want to show you really quick. A couple of resources. The first one I want to point you towards, in case you're not aware of it, is NASA's Year of the Solar System program, New Worlds, New Discoveries. This is an amazing website with lots of wonderful resources. You see the web link listed very prominently there. If you haven't visited the site, please do so today. Go there and check it out. Over on the left navigation section of the website, you'll notice topics. Year of the Solar System is a program that was developed with topics that have been structured around the big questions in planetary science. So you can see how these things are telling the story of our understanding of the solar system, as far as how it formed and how it has evolved and changed over time. How we're looking for different planets in life beyond Earth now. So lots of interesting topics there that you can explore and look at. You'll also find latest science news that you may find of interest, and there is also a section where you can get involved. You can register your events and programs via the Year of the Solar System map or calendar if you go to the Get Involved page. So please get down there and do that. If you register your program, we will send you a pack of goodies from Year of the Solar System, including bookmarks and flyers to help promote your program. And we'll do that as long as our supplies last. So please go there, check it out, and get involved with the Year of the Solar System. Share it with your contacts and anyone else that you think might find it useful, people that may not be aware of this amazing resource that is out there. And with that, we have one other resource, or one other event coming up we wanted to chat about. And I'm going to actually turn this over to Andy for a moment, because he had something special he wanted to add in to tell you about. So here's Andy to talk to you a little bit more about International Observe the Moon Night.
Okay, so some people have mentioned they participated in this event in the past. It's International Observe the Moon Night, or as we call it, INOM. This is the third year that we've done it. And it's basically just a day that is devoted to going out and looking at the moon. And of course, like we mentioned earlier, the moon is right there. You don't need a telescope. You don't need binoculars. You can look at it with your own eyes. So even if you don't have an event scheduled at your library or anywhere in your community that you know of, you can just go out, get some people together, go out and look at the moon, and then go to our website. You see it at observethemoonnight.org, and you can, there's a map where you actually see where events across the world are taking place. Right now, there are about 400 events that are on the map that we know of. That doesn't include events happening that they haven't told us, haven't registered on our website. So there's a lot going on with the moon right now. There are 3 different missions, 4 different spacecraft going around the moon right now, collecting data on the moon. So even though we don't have humans on there yet, gone back yet, there's plenty of lunar science happening, a lot of exciting things coming out about the moon. And one thing we just announced yesterday that we're doing for International Observe the Moon Night is in honor of Neil Armstrong and in the spirit of the request of his family, asking people to go out and look at the moon and wink at it. We are asking different events, locations holding International Observe the Moon Night events to take a picture of their participants winking at the moon. And then we have set up a Flickr page for people to go to and upload those pictures. So if you go to our Observe the Moon Night website, the URL you see there on the page, on the screen, go to event, or I'm sorry, if you just, up in the upper right, there's a slideshow of different things that scroll across in what's called the What's New section. There'll be a little thing about that winking for Neil. You follow that link, it'll take you to the Flickr group page, and you can post pictures of people winking at the moon. So even if you don't have an IOM event, you can still do that with your family or friends. Take a picture of yourselves winking at the moon and put it on that page. And if you just go to Flickr and do a search for Wink for Neil, that group page should be the only one that comes up, actually, at least it was yesterday. So I just want to share that with INOM.
Okay, and with that, we just want to again thank you. Thank you for coming today and taking part in this webinar with us and this training. Keep in touch. You see our contact information below there, explore@lpi.usra.edu, or you can feel free to contact me since you have my email as well. And let us know how things are going, or if you have any questions or are looking for something in particular, a resource that might be relating to these things. So the last thing I just want to mention is that we do have a certificate waiting for you. And if you take the survey from the SurveyMonkey link listed right here, once you submit your survey, it'll direct you to this online certificate, which you can then type your name into and print for yourself. So please take our survey. It's going to help us to serve you better in the future. and you can get your certificate in the process. And also, just one last thing, if you're interested, if you go to the Explorer website, you can log on or sign up for a basic account with our discussion boards as well, which is an area where you can contact each other and talk about how your programs are going, and kind of keep that networking up. The discussion boards will be going through a transition within the next couple of months, so stay tuned. We will be announcing those changes in the near future, but we will actually be moving away from the discussion boards more towards a listserv. So stay tuned for those. I will announce them and make it clear when those changes will go into place. So thank you for joining us today. I appreciate it, and I hope to hear from you and see your successful program pictures and descriptions soon. Have a great week.